Hello and welcome to the Olas Dev Academy. In this video, we will review how you can execute on-chain interactions with your service. There are three main types of interactions your service can execute. First, the service can interact with the Ledger API to retrieve information from the ledger. This information can be, for example, the balance of a given address or information about the latest block. Second, the service can read information from a smart contract. This involves accessing data stored within the smart contract without modifying it. This operation doesn't incur any gas cost. Finally, the service can write to a smart contract by sending a transaction. This allows your service to update or modify the data within the contract. This operation incurs gas costs. Please remember the following general considerations when interacting on-chain. Any on-chain interaction has to be encoded in a behavior and not in a round. Recall that behaviors are the components that execute the proactive actions in a service. Any on-chain interaction has to be executed through the tooling that is provided by the framework. This tooling is based on Python generators. For this reason, when you execute a call using those methods, they have to be preceded by the construct yield from. Finally, the usage of custom methods is discouraged. We recommend that you use the provided tooling to encode your service interactions on-chain. The reason why we discourage the use of custom methods is that interacting on-chain is a blocking operation. This could impact the agent loop and may cause that the agent or the associated Tendermint node crash. To retrieve information from the ledger, you need to follow 4 steps. First, you need to include the necessary packages on the skill.yaml. This is usually the Ledger API protocol. Next, you need to define the necessary handlers and dialogues in your skill, which is the Ledger API handler and the Ledger API dialogues. Next, you need to include the necessary configuration on the agent configuration file. This includes the OpenAI Python dependencies and some other information. And finally, you need to use the method getLedgerAPIResponse inside the main method of your behavior. Let's see an example on how this is implemented in a service. We are using the trader as an example service. If we go to Ledger, Packages, Valory, Skills, Transaction Settlement Multiplexer, this is a skill used by the trader service. So here in behaviors, we have this method here. We have a private method that is making a Ledger API call. In this case, we can see that the method to achieve this is the method getLedgerAPIResponse. So this is preceded by yield from, and it needs to be passed a number of parameters. In particular, the most important is the concrete method that we want to execute from this ledger. In this case is getBalance. Performative is usually set to getState in this case, and we also pass some additional parameter, which is the account address. In this case, we are checking the balance for this agent. So once this method finishes, we can retrieve the response. In this case, we need to examine this response object in the attribute state in the body, and we can see here that the result is encoded in this attribute called getBalanceResult. If we examine what is also needed in order to execute this query, So we can go to the corresponding skill. Here we can see that this skill is importing like the Ledger API protocol. This comes from the framework, so this is a package that comes with the framework. It also needs to define a couple of classes, which is the Ledger API handler and the Ledger API dialogues. So this is just boilerplate code. If you go, for example, to handlers, you can see that we are just importing this from the base class, which is abstract round ABCI handlers. We are importing it, and then we are simply assigning it to make it particular for this service. So this Ledger API will be associated to this skill. The same happens with the dialogues. Very similar story. So we are importing from the base classes here, and we are just defining it for this particular skill, so that there's no name clash with some other skills. Finally, if we take a look at the agent that's using this skill, so we will see a number of points. We can perhaps filter by ledger, as I have here. So there's a number of points. We can see that the agent configuration file needs to include some components. So it needs to include the connection, the ledger connection, also the protocol ledger API. It needs to define a parameter, which is the default ledger. In this case, we are giving it's of type Ethereum. Those are the required ledgers that are used for this agent. And in the Python dependencies, we also need to define which are the specific version from the AEA ledger that we require. So in this case, for example, if we focus on Ethereum ledger, we are using this Python package in version 1.50. So there's also more configuration to be included in this file. In particular, for the connection, we need to define what are like the concrete parameters for the ledgers that we are using. In this case, we define two possible configurations, because this service will be also working in the Gnosis chain. And as usual, this will be overridden at service level. So we define this, let's say, the address of the RPC, the chain ID. If it's a POA chain, the default gas price strategy. So you can check an existing service. You can follow the same strategy when defining these configuration files here. And if we go to the service, so these variables, these attributes will be particularized for this service. And as you know, then you can override this using these environment variables. Reading from a smart contract is very similar to executing a ledger request. We need to include the necessary packages. In this case, we need the contract API protocol, and we also need to include the specific contract that we want to read. We also need to define this boilerplate code for the handler, for the dialogues, and include the configuration also on the AEA config, the agent configuration file. And in this case, the method that we are using is get contract API response, which is very similar to what we were doing when reading ledger information. So obviously the parameters are going to change, but otherwise it's very similar. Using the trader as an example, again, if we filter by get contract API response, so we have a number of occurrences in the service. So we can take, for example, this one here, which is interacting with an ERC20 contract. So usually this has like this first parameter, which can be either get raw transaction, or usually more commonly can also be like get state. You can take this as just boilerplate code here. You need to pass to this call this the contract address. Obviously, the contract ID, this refers to the contract package ID. In this case, we assume that we are given this contract, so like working or building these contract packages will be scope of another video. For this video, we assume that we have this contract. So these contract packages, what it does, it is implementing the actual logic that will interact with the smart contract on chain. So we need to send the contract callable. In this case, it's check balance. So if we, for example, examine what this is doing here, so we see that in the end of the day, this is calling the balance of method on the smart contract on chain. And of course, in this get contract API response, we need to send an additional parameter, which is the account. So from this response here, we can pass the response, and in this case, we can get what is the token the token value, because it's an ERC20 contract, so this will be the value. And additionally, we also get some other data here, which is the wallet, the balance of the wallet in the native coin here. Obviously, this response, I mean the contents that you get on this response depends obviously on the call that you are going to exit to make to this contract. And in terms of examining what are the files, the configuration files, the skill.yaml and the AA config.yaml, we can see, for example, here that in this case, this skill needs to import at some point, in addition to what we require for the ledger. So this is using. So this has a section where it is importing all the contracts that it will be required for this service. In this case, the one that we were taking a look, it's the ERC20. It also needs, similarly as in the Ledger API, it needs the contract API, the package. It needs also to define the contract API handler, similarly as we need for the Ledger, and the same for the contract API dialogues. And then we need, and essentially that's it. So this is the information we need to take into account in this file. And if we take a look at the agent file here, it's Valory agents trader AA config. So we have a few instances of contracts. So of course we need to include as a dependency of the agent this ERC20 contract because it was a dependency of one of the packages that the agent is using. Also the contract API, and in principle this would be the main entries that we need to take into account in this file. The other parameters that we have here, it's parameters are being used for other purposes. In this case, the save contract address, which it will be explained in the next slide. So finally, we are covering how to write on a smart contract on-chain. So this is possibly one of the most complex operations that the service needs to do. And the reason for that is that agents need to reach a consensus when they want to sign a transaction. So remember that each service is represented on-chain by a Gnosis safe. Writing on a smart contract requires a multi-sig transaction. So this means that a threshold of agents need to reach agreement on signing this transaction so that it can be executed and sent to the ledger. And the transaction settlement ABCI skill, which comes with the framework, manages transaction signing and settlement on chain. It manages how the signatures are generated among the agents, collects the threshold of signatures. If it's required, it retries the operation in case there's some error, and it also takes into consideration some other potential issues that may happen in this complex procedure. The requirements for this operation is somehow a bit more complex than just for reading from a smart contract. So the first three steps are very similar. You need to include the contract API, the contract packages, define the components in your skill, and include the necessary configuration in the aa-config.yaml. In this case, you also need to provide the service safe address. You also need to execute some additional operations. You need to chain appropriately your skill with the transaction settlement ABCI skill. When you are inside the method that you want to write on a smart contract, you need to prepare this safe transaction, and then your service needs to transit to the transaction settlement ABCI skill, which will take the transaction that you have prepared. This transaction will be stored on the synchronized data. It will take this transaction from the synchronized data, and it will settle this transaction on chain. So in order to have it more graphically, this diagram represents like a template for services. We usually on services have this initial agent registration ABCI app. This comes with the framework. This reset and pause, which also comes with the framework, and the transaction submission ABCI app. What you program for your service, the business logic usually comes here in the middle. So you have your skill, which has a number of states, and at some point you have some transaction preparation stage where you prepare this stage for be submitted on chain. And when you have finished preparing this transaction, you transit to some final state, and this final state will be chained with this transaction submission. So this will be how the chaining for this particular service will end up. So just reviewing the part of the transaction submission. So in this case, so again, your service starts with this registration. It transits to your ABCI app. You have a number of states, and you decide here that you need to prepare a transaction. So you prepare this transaction, This is a placeholder state. You do nothing here. It just allows you to transit to transaction submission. And once transaction submission has finished settling your transaction, you need to rewire where you want this state to go. In this case, we are simply transiting to the reset and pause, but of course you can wire this according to the needs of your service. Now let's examine how this is implemented at code level. The configuration of the skill and the agent is very similar to what we already need for reading a smart contract, so we are skipping this from this video. To examine the code itself that executes this transaction, we will be using the Autonomous Fund service. You can also find this service on the GitHub repository. So if we go to packages, balancer, skills, pool manager, so we can open here this behavior, which is called update pool transaction behavior. This behavior starts with an async act. So this behavior is in charge of preparing the transaction, assuming that it has gathered enough data to execute this transaction, or it is gathering this data within this state here, within this behavior. So if we go to the async act, which is the main method here, we see that the way this works, the main logic is in this method here, which is called get save transaction. So the other parts of the logic, it's a kind of boilerplate or required code. But if we go to this method, get transaction, this method executes 2 steps, which is typically what you need to execute when you want to execute on-chain transaction. In the first step, what you need to do, or what your service needs to do, is to prepare the transaction of the contract that you want to execute. That is the actual set of instructions that you want to execute on chain. So this, of course, is dependent on the contract you want to interact. So in this example, it is interacting with the manage pool contract. Again, you don't need to understand what this contract is doing. It's calling this method, which is update weights gradually. The second step is prepare the save transaction, which is embedding these instructions that you have on step 1 into an actual save transaction. And this has to be done through the save contract associated to the service. So let's examine how is the first step implemented here. So the first step is implemented in this contract call here, which is get update weights gradually transaction data, and this returns an object. Again, this has to be called using this yield from to avoid the logic of the agent loop from being stuck. So if we examine this method here, so you can see that it takes some parameters, it collects some parameters that then are sent to this contract call. And in this contract call, we are essentially calling this method, which ultimately is calling the actual contract method from the ABI. And this method is in charge of preparing the transaction, the encoded set of transactions that this contract needs to execute with the required parameters here. So this is very similar to a contract read, as we saw in the previous slides. And once we have this response here, so we can we need to parse a little bit this response. So this will be X encoded. So we need to strip this 0x from the beginning, so that's for the format on how the transactions need to be encoded to be sent to the safe, and we return this data. So in summary, so this method here is just returning the encoded instructions from the actual smart contract we want to execute. In the second step, we need to take this transaction or this encoded set of instructions and build the actual safe transaction, the transaction that needs to be signed by all the agents. So here after we get this data, so we make some checks here, and now what we need to prepare is this safe transaction itself. So we are sending the set of encoded instructions from the previous step, and let's take a look to what happens inside this method. So in this method, so we need to execute a contract call. So it's like the method is called getRowSafeTransactionHash. And as you can see, we are in this case interacting with the Gnosis safe contract, and the address in this contract is the contract safe. It will be the address of the safe of the service. In this case, it has this particular name, but this is obviously interacting with the safe. So we also need to include the data that we want to execute. In this case, this data comes from the previous call, which is encoding the transaction we want to execute. We need to also to add some value. In this case, will typically be 0 because we only want to execute this instruction and the safe gas. After this finishes, so again we need to strip this 0x from this transaction, from the return value after creating this transaction, and this will return the actual transaction hash. So the next step we need to do is to take this hash for this transaction. This is the hash that will be signed by the agents in this multi-sig safe. So if we continue with this examining this method here, this hash is returned here at this point. This hash it depends on this on the set of instructions that we have sent. And now we need to build the payload for the transaction submission ABCI app. So this is built using this method, which is called hash and payload to X. So this takes the hash that needs to be signed and also the data that needs to be executed for this contract. It has some other parameters like the to address of the safe in this case, and some additional values like the ether value, the safe gas. So those are the values that were used when we built this safe transaction hash. So if we go to this method here, so this method comes from the transaction settlement ABCI, and essentially it bundles like a collection of data so that this skill can understand it. So you need to use this method from the transaction settlement ABCI. So once you have built this object is retrieved at this point here, the safe transaction, and this is built into the payload, where you need to build this payload sending this safe transaction. So now that we have sent this this payload to the Tendermint consensus layer, so now let's see what happens on the counterpart, on the round counterpart here. So if we go to this, to the associated round, to this behavior, we see that this round is, in this case, it's using this extended end block, like overriding this end block method. You can also have the, the more compact form where you don't need to override this end block method. But in this case, the important part here is that it's updating the synchronized data most voted transaction hash with this most voted payload, which will match with the payload that was created. So this is the parameter of the synchronized data, where you need to store the transaction that was populated in the behavior. By the way, this name, like transaction hash, it's maybe a bit misleading, because here this object actually it's containing both the transaction hash and the set of instructions from the contract, the encoded instructions. If you remember here, we are using this method, which is called hash and payload 2hex. This is like finally what it is going sent to the consensus layer. If we go to the end block, this is what is being stored in the most voted payload, and we are assigning this to this value here. So it's also convenient that you that you also set the value transaction submitter as this self auto-run ID, meaning that this the transaction submission step knows which is the round that this transaction comes from. So the final step will be that at this moment, when we send the event done, we need to transit to this transaction submission ABCI app. If you remember from this slide here, so we are now at this step, so we need to transit to this. Sorry, we are at this step, so we need to first go to a finished round, and then we can wire this to the transaction submission ABCI app. So let's see how this is implemented in the code. If we go to rounds, let me first copy this name. If we go to the rounds here, so we see that this when this round has finished executing or preparing this transaction, it goes to this finished transaction preparation round. If we copy this and we go to the composed skill, the composed skill is in this file here, autonomous fun ABCI composition.py. So if we browse for this method, we can see that here, when I am on this final state, which is a placeholder state, I transit to this transaction submission randomness transaction submission run, which is the initial state from the transaction submission. And if we go back again to this slide, so we have just implemented this step here. So this will take charge of executing the transaction. As commented, this will also handle some error situations like retries and so on. It will handle the signature of the agent. And once we finish, we need to rewire these final states, the fail or the success one, to the appropriate place in our composed finite state machine. So let me check here. If we examine in this composition, what are the different ways? So as you can see here, this is a successful submission round, which transits to this post-transaction settlement round. And when it's a failed round, it transits to another one, which is called allow list update round. But obviously, this highly depends on your service. So with these steps, we conclude like reviewing this, how to write on a smart contract. And this is the end of the video already. So thank you very much and see you in the next video.